Hi guys, welcome back. I think you can hear me loud and clear. In this session, I'm going to discuss network analysis PYQs, basic PYQs. At you should know it's not how to solve, you should know rather how to solve in a short time. Time is a constraint for any competitive exam. Knowing the concept is definitely first thing. Doing it quickly in the exam, that is another important thing. So we'll see both of these in this session. Okay? Yeah. You can visit our website courses.pi2.in for some free videos, free practice tests. Yes, we have free practice tests. Of course, for free tests, no solutions are available. If you want detailed solutions, you need to go for paid test, but you can appear the free test for the practice. Okay, download our app or go to our website. You can check the link in the descriptions. Okay, or else if you want some free video lectures also, you can WhatsApp us asking for, sir, I want free lectures for this specific subject. Our team will help you on that. If you want handwritten notes, you can contact us on WhatsApp. I want handwritten notes for this specific subject. Our team will send you that on WhatsApp itself. Okay, so let's get to the first question of network analysis. Interesting question. So you should be solving this question under 60 seconds. You just try to solve this question in 60 seconds. Just try. Just try. This is not that difficult if you know the concepts. Here, our objective is of course solving the questions, but solving questions in very short time. Okay? Yeah, go for it. Go for it. Your videos are really awesome. Thank you, dear. Because it's not my a single effort. Our team is building the animations very nicely. You know, for every video, we'll take a lot of time to build it. I think you solved it. You solved it. AP electrical jobs, I think you're trying to ask. Any update? No update here. No update yet. I think which is known to you, but this month end, we're launching a campaign. I want you to be part of that campaign. Okay, this month end we'll launch that so that in the next year itself, we'll try to push the government. Okay, we'll come to that. I think your time's up. What will be the power consumed by the voltage source and current source and resistance respectively? So it is asking, be clear, it's not asking power delivered by the source. It is saying all three parts, one thing, power consumed. Now you may say, sir, this will deliver the power. They are active sources. They will deliver the power. They deliver power. Careful guys, I made a video on YouTube itself. It's not necessarily active elements always deliver the power. It's not necessary. There are some cases they may absorb the power also. There are some cases it is neither delivering nor absorbing also. Yes, there are cases. We made a video on YouTube itself where active power is consuming the power. Just why to make a video? You know your phone, mobile phone battery, the phone what you're watching right now. When you charge your mobile phone, battery is there, that is active source, active element, but when you're charging, it is consuming the power, right? So don't think that active element means always it will deliver the power. No, that's not the case. All right. Anyways, these kind of concepts also we learn along with these questions. Anyways, coming to this. So if you follow our courses where I gave beautiful diamond rules, if you follow 4 diamond rules, these 4 diamond rules from network analysis, your network analysis will be a lot more easier. Just 4 diamond rules. Okay. In the first diamond rule, I said about resistance series and parallel. Second diamond rule is about voltage. So here I have 1 volt source, means this voltage is 1 volt, this voltage is 1 volt. If this voltage is 1 volts, current flowing in this according to Ohm's law is 1 ampere. Is 1 ampere. According to KCL, incoming current is 1 ampere. This outgoing current is already 1 ampere. So this current will be how much? How much? Just give it in the comment. Just give it in the comment. How much will be this current? Yeah, quick. Yes, 0 ampere. Don't think that everybody knows. I'm not writing in the comment. You should write in the comment. That's how you're training your brain. Okay, so this is 0 ampere because of the KCL. We applied here Diamond rule, we applied here Ohm's law, we applied here KCL. Okay, anyways, now 1 volt into 0 ampere is 0 watt. So this is 0 watt. It is asking a sequence of voltage source, current source and resistance. Voltage source is 0 watts. Means these two are wrong answers, either B or D. Either B or D. Now the current source, coming to the current source, 1 volt 1 ampere, it is delivering the power. It is delivering the power. Means if it is a passive element, if it is consuming the power, then current entering terminal will be positive. Current entering terminal is positive, which means it is consuming the power. Which means it is consuming the power. Here, current leaving terminal is positive, means it is delivering the power. How much? 1 ampere into 1 watt, which is 1 watt, which is 1 watt. Where is it? Yeah, it is delivering. Careful here, guys. Careful here, guys. It is, I said 1 watt delivering. Okay. Now coming to this. Now coming to this. Now coming to this. This is I square R or V into I, whatever you say. You can say this one is 1 watt. It is consuming the power. So this is 0 watt. This is 1 watt delivering. This is 1 watt consuming. So answer must be 0. It is said minus 1. Why it is minus 1? But if it is this 0, 0, 0, this is not the case. But in this case, 0, 1 and 1 should be there according to our answers. But it is said 1, 0, minus 1 and 1. Why it is minus 1, tell me. Why it is minus 1, tell me. I want your quick answer in the chat. I want your quick answer in the comment. Every one of you. Quickly, why here it is minus 1 option is there? Can I go for it? Can I go for it? Yes. Yes, it is 1 watt delivering, means plus 1 watt delivering, but the question it is asked for power consuming. Plus 1 watt delivering means minus 1 watt consuming. Or in the same way I can write this one as minus 1 watt delivering. Both are same. I can write in case of a resistance minus 1 watt delivering I can say, or if it is this minus 1 watt consuming I can say. Both means just the same. Just the same. Okay, so answer is B. Okay, answer is B. Guys, network analysis basics are really very easy if you know the concepts. If you know, free videos are available, guys, for you guys, because we know the importance of network analysis. That's why we made the basic videos free for you. Just download the app. There you experience these free concepts absolutely for free, so that this will help you a lot in understanding for the lectures. Let's go to the next question. You try to answer. This is a simple one, man. This is a simple one. I think you'll be able to answer it in 10 seconds, maybe. Just in 10 seconds, but crucial one. There are a lot of LAMP questions in TRANSCO, ZENCO and these exams. LAMP-based questions will be there. For those LAMP-based questions, these concepts will be, this is a basic one for those LAMP-based questions. Here out of focus over here. Okay, set. Yeah. Somebody saying 20, somebody saying 40. Let's see. Let's see. Resistance of, guys, here, don't get confused here. Concepts will be, if it is power case, sometimes we'll say power is proportional to resistance. Sometimes power is proportional to resistance, means higher the resistance, higher the power. It is not always true. Sometimes we'll say power is inversely proportional to resistance. Now, in which case this is true, in which case this is true? It has both. It's not just power is always proportional to resistance. It's also true power is inversely proportional to resistance. Now, in which case we should use what? What are the cases? Guys, tell me. Guys, tell me. Our objective is not just to answer the questions. Our objective is to recall the concepts nicely. Recall the concepts nicely. Tell me. Tell me. First one series, second one parallel, something like that. You're saying very good, guys, very good. If I put those words in a more technical way, of course, that is also technical. What you said in technical, I think Madhuteja is saying, Sampath is saying, and Mahendra Naidu is saying, all what you're saying is absolutely right, guys. But I'm just putting it in a little more technical way. This is true. This is true. Guys, be careful. Don't get confused here. This is true once current is constant. When current flowing through the element is constant, you can say power is proportional to resistance. It's irrespective of being series and parallel. Of course, series and parallel is a more better use case, but when it is this, power is inversely proportional to resistance when voltage you are fixing constant. When you are fixing voltage as constant. Alright? Now in this, it is said voltage is 200 volts fixed. Voltage is 200 volts fixed. Now it is said 100 watt. Now it is asking for resistance. So I should be using this formula. I should be using this formula. In this formula, when I use it further, this will be an inversely proportional relation you are going to get. Okay? This is a key point which you should never miss. Alright? Let's see using this formula. Let's find out this. See, our objective is not just answering question. Recalling the concepts with the help of these beautiful questions. When you're attempting the practice test, your objective is not just, of course, when you're answering it, your objective is to get the answer, but when you're analyzing it, maybe half an hour test, you may take 3 hours of time to analyze. More than 3 hours of time to analyze just a half an hour test. Why? Why? Because during the analysis process, you should recall all these concepts, even for the right question also. Not just for the wrong question. For the right question also, you should be able to understand and analyze the behind concepts. Alright? So, power is equal to V square by R. You don't have to get into the calculator to answer these kind of simple questions. I asked for resistance. Resistance is equal to 200 square by 100 watts. It's gone. So 400 ohm. Option C is the right answer. Most of the people have given right answer. Most of the people. Very good, guys. Nanu has said it perfectly for this. For voltage constant, P is inversely proportional to R. Perfect, Nanu. Thaliya bajao bhai sabke liye. Those who said right, yeah, this blast is for Nanu because he's more specific. Okay? Good. Let's get to the next question. Yeah. Try this out. अभी सेट हो गया ठीक है या is it still blur guys yeah I think our team has fixed it got fixed guys the blurriness got fixed yeah Madhurya is saying answer B he's the first one to answer let's see others what do you got to answer for this Okay guys, I'll give a simple tip here. To answer these kind of questions. It is said when 100 watt, careful guys, be careful. Next time when you encounter these kind of questions, you should not waste a lot of your time. Usually these kind of questions you will get a right answer, but it is gonna kill some of your time. But I'll give you some tip now. With that tip, the time you're not going to kill. Okay, let's focus on the tip what I'm going to give. Understand these guys. You have two bulbs. Connected in series. One is 100 watts. Careful guys. Another one is 25 watts. Both are of 100 volts. Careful. Both are of 100 volt capacity, 100 volts rating. 100 volts rating both are having. Now they are connected in series. That's what the question says. Now with this, let me just add some more point for the information what is given here. Which of these two bulbs have, don't get confused. When you think about series and parallel, power is proportional to R, power is inversely proportional to 1 by R. You may get confused. But if voltage, for the same voltage, both are having same voltage, now tell me which bulb will have high resistance? I want you to be quick on this. Which bulb, R100, R25, is this symbol in between here, is it equal symbol or greater than symbol or less than symbol? This is a key point. Which symbol I should use here, greater than, less than or equal to symbol? Absolutely guys, this will have high resistance. Why? Because voltage is same. First of all, you should not directly comment, sir, low power, we know P is equal to I square into R. Low power, low resistance. That is not a correct logic to apply in this situation. That's not the correct logic. Why? Because the case is given for same voltage. If it is the same voltage, you have to apply inversely proportional logic. Means lower the resistance, higher the power. Lower the resistance, higher the power. Higher the resistance, lower the power. So this is the relation. This is fixed. Fix this first in your head. Whenever you get this kind of a question, first of all, relatively, you don't have to give exact values for the resistance. Relatively, qualitatively, you try to give resistance values what is what. I have written this. Let me just keep this information aside. I have made an observation. I'm keeping this observation aside, which is very essential for answering this question in the shortest time. Now what is said? Is, for this series connection, I am applying 200 volt supply. If 200 volt supply is used, I have two resistances whose this resistance is higher, this resistance is lower compared to this resistance. If this is clear to us, I don't know what are the values. I don't have to know what are the values. Under this case, I can clearly say from the voltage division rule, the voltage across this will be definitely greater than 100 volts. Because if resistances are equal, voltage will divide equally 100 and 100. But this has more resistance. If this has more resistance for the same current, according to Ohm's law, V is equal to I into R. If current is same, voltage is proportional to resistance. Higher the resistance, higher the voltage. So this voltage is more than 100 volts. If this is designed to handle 100 volts, but the voltage appeared is more than 100 volts, boom, this is going to get damaged. 25 watt 100 volts lamp will fuse, will burn. Nothing will happen to this. It will not either glow nor blow. It will be as it is. Because it is blown, it is open circuited, it will be still there in the circuit. It will still there in the circuit. So this is not the answer. This is the answer. Okay? Okay? Anything else, guys? Did you learn something? Whenever you get these kind of questions next time whenever you get these kind of questions, what you should do? You should immediately write this resistance relation for the respective bulbs by keeping both the conditions in your mind. P is proportional to R, P is inversely proportional to R. Then you go for it. Okay, I'll repeat, buddy. I'll repeat just a slide. Dhanush Kumar is saying, repeat, just go back and watch again. You will understand it. You will understand it. Okay. Anyways, let me go to the next question. We have some more questions, some more queries in the chat. If individual voltage is constant, then P is inversely proportional to R. Perfect, Kalyanji. Perfect. Very good, guys. Very good. Very good. Keep it up. Everyone, press that hard to everyone. Dimly glow, sir. Which one dimly glow? Nothing will dimly glow. Once it is blown away, once it is melted down, it is open circuit. Once it is open circuit, your current will not flow in this. This is burned. Open circuit, there is no current. So, yeah. Next question. Here, objective is not just answering this question. Objective is the way you should handle the question. Next time, whenever you get a question in the exam, how to save your time in the exam. That's a key point you should learn from this. All right. Next one. Yeah. Try this. Try this. This is something interesting. You may get trapped here. You may get trapped here. I mean, you may kill some of your time. Okay. Yeah. Go for it. Yep. Are you trying or not? Wow. Sampath has got the answer. Amazing. Based on the opinion. Wow. That's even more amazing. Yeah. Continue thinking. Continue thinking. Okay. Let me give the answer. Let me give the process rather. Yeah. In the circuit shown in the figure, the current I is. Look at this, guys. If you go for finding out the specific answer, it's not a fill in the gap question. If it is a fill in the blanks, then you may have to go for solving the question. You may have to go for solving the question if it is a fill in the blank. Okay. Now the way Sampath has said, he looked at the options and he made a possible guess and it is right. It has to be right. It's not a possible guess, means not a wild guess. Let's see how Sampath has made it. First of all of you give a claps to give that heart symbol to Sampath for his amazing interpretation. Yeah, do it. Everyone, do it. Good. Pump some hearts to Sampath. Yeah. These two are in parallel. For parallel combination, always you don't have to do R1 R2 by R1 plus R2. You don't have to always do that. There are some beautiful tips you can do it. With that tip, I can directly write these two parallel combination is 4 by 3. And this combination directly without doing anything, I can write this is a 3 by 4. 3 by 4, 4 by 3. Okay, which means, careful guys, which means suppose I'm just writing here these two resistances. This is 3 by 4, This is 4 by 3 and this is 10 volts as it is. This is 10 volts as it is. This is an equivalent representation of this. Okay. That's what we gave all of these beautiful tips in our course. Even in our free videos also. Yes, absolutely. Madhuteja is saying that method also. The method what I applied here is RNR method. RNR method I have used. Give that hearts to Madhuteja. Okay, RNR method, which we have given exclusively at PiSquare RNR method. Of course, different people learn different way. That's a different thing. So now, coming to this 3 by 4 and 4 by 3. It is something close to 4 by 3 is something close to 1 point something. Okay, and 3 by 4 is, if I just add these two up, I don't have to be exactly, I don't want exact decimals and all. I can say it is something close to 2 amperes maybe. I mean 2 ohms maybe. This is 2 ohms. This total is 2 ohms. Approximately I'm just making the numbers. Approximately I'm making the numbers. Okay. If that is a case, that approximation, will it work? Yes, it will work. If that is the case, 2 ohms. So 2 ohms means 5 ampere is a current which is flowing in this. 5 ampere is approximately current. Okay. Now that 5 amperes is going to split between these two. Okay. And obviously whenever you see this, the first thing you should do is, can you say, is this a Wheatstone bridge? That's what the thing you should think in the first go. Okay. That's what the first thing you should do. Is this a Wheatstone bridge? Yes, think. Are you confused? Is it looking like a Wheatstone bridge? Yes, it is a Wheatstone bridge. Don't get confused. But bridge is not balanced. Yes, unbalanced. Look at this. These two arms bridging, you are not having any element. Rather, it's a short circuit. So every time you see, there will be a possibility sometimes for the Wheatstone bridge. You have to be careful with that. Anyways, this is 5 amperes approximately I'm making it. So that 5 amperes, it's going to split between these two. So what is the possible current here? What's the possible current here? And this current and this current. So if you know this voltage, what is the voltage here? This voltage will be voltage across this. If this is V1, this will also V2. Which voltage is less? Tell me here. V1 is less than V2. V1 is less than V2. Why I'm saying V1 is less than V2? It is because this has low resistance, this has high resistance. Okay, just a qualitative guess here. Anyways, coming back to this, this is 5. This is current division rule. If you apply quickly, 5 into 3 by 4 is a current flowing in this. You don't have to necessarily do this current division. You can also apply voltage division here. Find a V1 and V2. And if you keep that V1, V2 values here exactly by using Ohm's law, you'll find this current and this current. There are a couple of methods you can apply. There are a couple of methods you can use. All right. So let me just go for this qualitative method of finding the voltages first. Because that's going to be easy for us. We're making anyways a qualitative analysis. Okay. So we got approximately current is 5 amperes. So this voltage here will be 15 by 4. And this voltage here will be 20 by 3. So this is just approximate number. This is 15 by 4. This is 20 by 3. Now tell me, current in this is qualitatively again, this is a 15 by 4 ampere here, because 1 ohm is a resistance. This is 15 by 4 ampere. This current is how much? This is 10 by 3 amperes. Am I right or not? Rough numbers, not exact numbers. Now this current is positive or negative. Applying KCL here, this current is positive because 15 by 4 is here, this is 10 by 3, so this current is positive, so A cannot be the answer. A cannot be the answer. Okay, now what is the possible answer now? I'm just guessing. So 24 by 5, this will be something close to 4, something close to 5 even, 5 ampere. This will be something close to 4, let's take 3.8 something, let's take it as 4. This is in decimals. Now, if I subtract these two numbers, means 15 by 4 minus 20 by 3, is this gonna give this answer or this answer? 5 or 4? Definitely it's not gonna give 5 or 4. So possibly D is a possible answer. And it is answer. Okay. And if you go for exact numbers also, you will get the answers. If you go for exact numbers also, you'll get the same answer. Exactly, you'll get 2 by 5. But I don't recommend you guys to go for exact analysis all the time. Sometimes approximations, when you get options, try to make use of those options for easy answering. Okay? Are you clear, guys? Are you clear? Confused? Just check it again. You will get it. Just check it again. You will get it. Okay? Shall I go to the next question? Yes. Let's go to the next question. It's easy one. Looks complicated, but it's easy. Try. Stop thinking. Try. You're thinking too much, I think, huh? Very good answer by Madhuteja. See how smartly Madhuteja is doing. He simply said 150 volts. Means he actually said the answer. You don't have to find out the current. If you know the voltage, look at the options. That's what the beauty of options. Okay. So somebody is asking, Dragon is asking, from which side we have to solve this question. Okay. That's what, guys. It's not, some people will say you should start solving from this side, top side or bottom side. There is nothing like that. If you know the concept, you can solve it from any side. Concept is key point. Don't try to consider which side. Okay. Buddy, Dragon, you just check, go to our app or go to our website. Check the free videos of network analysis in individual courses. We got some free videos. Try to watch those free videos. In those free videos, if you watch it, you will get a complete clarity on basic fundamental concepts. Okay? Yeah. In the circuit shown in the figure, Vx and Ix are. This is Vx, this is Ix. It is asked to find both. Luckily, if you find voltage, because voltages are all 4 distinct values. If you find a current, if the current is 10 amperes, then you may have to check between these two. Okay, so first I'll try to solve the voltage, because if I try to solve the voltage, directly I will get the answer. If you see this, 2 ampere. So voltage across this is, according to Ohm's law, 2 ampere into 50 ohm, which is 100 volts. So voltage across this and this, both are 100 volts. So current flowing, this is 1 ampere, again Ohm's law. If you apply KCL here, 2 ampere, 1 ampere, this current is 3 ampere. This current is 3 ampere in this direction. Direction also very important, extremely important. Extremely important, because in the option there is a minus, and also be careful. Okay, in this direction, so the voltage is 3 into 50, 150. Is the 13 ampere. Answer is option A. Answer is option A. Not 10 ampere, buddy, it is 13 amperes. Because this current is 10, you need to add this current also, Madhuteja, KCL. Are you clear? Are you clear? Oh, answer, you're answering it. You're answering it. Okay, good, 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 good. Good guys. Good guys. Keep it up. Keep it up. Okay? Yeah. Yeah, fine, fine. Next question. Okay. Dragon was saying from the right side it's gonna be easy. Okay, Dragon.
ఎవరురా నువ్వు ఇంత టాలెంటెడ్గా ఉన్నావు?
Clear? No answers, I got it. What happened? What happened? Okay. Let me solve it. Let me solve it. I think you guys are taking more time. See, it's not just answering the questions. You have to answer it in less time. That is also key point. That is also key point. Okay. Now it is asked for finding current in this. Suppose if the question would have been find the current in this, not here. If the question would have been asked to find the current in this, what is the easiest method to get it? Just write it. Just write it. Yes, Vinayji. Hi. Vinay always sends hi into 100 or into something, not just single hi. Always he does that. Thinking, some people are saying source transformation, some people are saying nodal. But they are not correct. The actual answer for this is not answer. What I was asking for is, I was asking what is a method if the current asked in this branch. You should apply the easiest method. It should strike to your mind is, what is a theorem? Tell me, fill this theorem. I am writing first letter also, blank and theorem. What is a theorem which will easily give the answer? Yes. Think. M, it is starting with the letter M. If the question asked for this current, you should apply Milliman's theorem. Milliman's theorem will give direct answer if the current asked is here. But current asked in this branch, current asked in this branch. So you have to apply superposition or nodal analysis will give the answer. Definitely nodal analysis also will give the answer exactly what our somebody was saying that Dragon Marvel was saying. This will also give the answer. Okay, now superposition, because it's all 6. Let me not get into the equations. It will be easy if I go for superposition theorem, but yes, nodal also will give it in a single shot. Okay, because only single node is there, only single non-reference node is there, only one equation you will get. If you solve that equation, you will get the direct answer. All right, anyways, coming back to this superposition, I'm just short-circuiting this. So I prime is equal to, these two are parallel, 3 plus 6, 9 by 9 is 1 is divided between these two, so I prime is 0.5 ampere. Are you guys confused? I just said this is short-circuited 6, 9 and all. Confused? There is nothing to get confused if you know the concepts what I taught in the free videos of network analysis. Okay, very easy, guys. All right, try it out. Now, next, you short circuit this, and find out current in this double prime. So definitely current, I'm finding this current, and these two are in parallel, 3 and 6 in series, 9. So current is minus 6 by 9, which means 2 by 3 ampere. This is 1 by 2 ampere. This is 2 by 3 ampere. Sorry, minus 2 by 3 ampere. So I is equal to algebraic sum of I1 and I prime and I double prime. Means simply 1 by 2 plus minus 2 by 3. 1 by 2 plus minus 2 by 3. If you solve it, you're gonna get 1 by 6. 1 by 6 as answer. Okay. Anything missing? 3, 2 by 3, fine. No, it is supposed to be minus. Minus 1 is missing somewhere. Minus sign is missing somewhere, guys. Let me just check whether question is correctly taken or not. I think there is some problem in the options and taking the options. Okay, this is supposed to be minus sign. Option is supposed to be minus sign. All right, guys. Did anyone got Madhuteja? Madhuteja has got correct, negative. Yes, guys. Good. There is some glitch. Very good, guys. Very good. Keep it up. In taking the options, so this is minus 1 by 6. Okay, answers. So this is 6 by 9. This is minus 2 by 3. And 1 by 2 minus 2 by 3 is minus 1 by 6. This is one way. It is asked current. Suppose if the options in the exam also given like this, all these options are not correct. Any one of these are not correct. Because minus sign has significance. You should get marks for all. Now guys, be careful here. I try to explain if it is asked current in this branch, Millman's theorem will be easy. But in this case, question is asked in this branch, so I have applied superposition theorem. Now, is there any scope to solve this question by using a Thevenin's theorem? Tell me. By using Thevenin's theorem, is this possible to answer this question? Yep. What is the possibility? I'm just waiting for your response. Thevenin's, guys, which is beyond your imagination, I think. That is pretty much possible. That is pretty much possible in an easier way. Rather, it's going to be more easy also. It's going to be more easy also if we go for Thevenin's concept. Thevenin's concept. What is the Thevenin's theorem says? Thevenin's theorem says, don't think that there are lot many steps, sir. Why should I do all those steps for this simple circuit? It's not lot many steps. If you know the concept, in direct one step you can write what is Thevenin's theorem. Let me consider this one as a load. So I just kept this load separate. This is 6 volt load. So this, for this circuit, I'm trying to find out Thevenin's resistance. Can you tell me what is the Thevenin's resistance for this circuit? Quickly, short circuit this. These two are parallel. 6 and 6, 3. 3 plus 6, 9 ohms. 9 ohms is a Thevenin's resistance. And what is the Thevenin's voltage? Can you tell me? Thevenin's voltage is, one way is open circuited, 6 equal resistances, 9 volts equal voltage. This is 4.5 volts in one shot. In one shot, you got the Thevenin's circuit. Now, I'm connecting load now to the Thevenin's circuit. It is asked to find out this current. Simple Ohm's law. I is equal to minus 1.5, or to be more precise, I should write 4.5 minus 6 by 9, which is 1.5 by 9. 1.5 by 9. Okay. And you will get, sorry, minus 1.5 by 9, I mean. Okay. You will get 1 by 6. You will get 1 by simply 1.5, just multiply twice. So 3 by 18 minus 3 by 18 is this. So 1 by 6 minus 1 by 6 is this. Okay. Did you learn something, guys? So source transformation, we cannot really make it easier with the help of source transformation, but that's a good attempt. That's a good attempt, Sampath. We just try it out. You just try it out. Okay, Sampath is saying source transformation I can use because it appears like that's a trap. It appears like you can use source transformation because this can be converted into current source. This can be converted into current source. You will not get much help because I said a key point in the source transformation. The source transformation or star delta transformation or any transformation for that matters. Any transformation for that matters, if you want to do, you should not disturb the element of interest. You should not disturb the element of interest. The element of interest is this. By using source transformation, if this is got disturbed, you cannot get the answer. So that's not easy way. Okay. Yeah, using node analysis. Yes, Madhuteja, you're right. You're right. Very good. Very good. Anyways, guys, let's move to the next question. Where is it? Oh, it's here. Okay. I think this is easy for you to solve. By the way, are you clear with the previous question where I discussed a couple of things like Milliman's theorem? All clear? Good. Thevenin's superposition. Yeah, that's what the PiSquare style. That's what the PiSquare style
అట్లుంటది మనతోని.
means. You'll get to see different ways to solve single question and you have to find the easiest way. We got the answer. We got the answer. Somebody saying 10, somebody saying 12 watts. Let's see who is correct. Let's see who is correct. Both of you verify once. Both of you verify once. Look at the question. In between, guys, our team is playing some crazy memes. They're trying to match. I don't know. Yeah, no further question, no further responses, guys. What happened? Come on. Only 2 people responded. 3. Anyways, let's see. Let's see. The total power consumed. Total power consumed quickly. 2 volts, 2 ohms. So this is 1 ampere. So this is 2 ampere. 2 ampere current is going this way, 1 ampere current is going this way. So this is I square R. I square is 4 into 2, which is 8 watts of power is consumed in this, and I square is 1 into 2, 2 watts is consumed here. 2 plus 8 is 10. And these two are delivering the power. How much? 10 watts is consumed, means 10 watts must have delivered by both combinedly. That's it. That's it. Power consumed means 12 watts. Please tell me, dear, how? Sampath was saying 2 square plus 1 square plus 1 into 2 volts. Okay, interesting. So they're trying to say this, they're trying to say this also. Let me just give that what they're trying to say. This consumes 2 watts of power. I'm just trying to explain your way. You're thinking that this is 8 watts, this is 2 watts, right? This is what you're saying. And let me just see what is the other possibility. Oh yeah, you're right, guys. You're right. It's not A. It's not A. You're absolutely right. Because this current is 1 ampere. This current is 2 ampere. If you apply KCL here, this current is again 1 ampere. Absolutely right. Absolutely fantastic, guys. Who is that? Sampathji and Shani. You're amazing. Give that hearts to these 2 guys. You're amazing. Because this current is 1 ampere in this direction. This current is 1 ampere in this direction, means this is also consuming 2 watts of power. And this 8 watts, this 2 watts, total 12 watts is delivered by this source alone. There is a trap. We all got trapped except these 2 people. Amazing answer is B. Amazing, guys. Amazing. Very good. Keep it up. Current enters the positive terminal means 2 volts also consuming. Absolutely, Shani. Absolutely. Absolutely right. Absolutely right. Good. Keep it up. No violation of KCL. Anyways, this is perfectly perfect. Okay, shall we go to the next one? Good. This is easy. This is easy. And Shani and Sampath, perfect job done. Perfectly done. Perfectly done. Yes, go for next. We got the answer. Oh, Dragon is saying diamond rule 2. Wow, क्या बात है Dragon साहब, क्या बात. Perfect. Okay, क्या नहीं, मस्त. He just said one line diamond rule 2. That's enough. That's enough. Sampath is saying 52, but 52 is not there. I think it's 42 maybe. You just see this 3 ampere is a current flowing in this, 3 ampere is going in this. This is plus, this is minus, this is 36 volts. I mean, you start here, come back to here, following KVLs and conventions. Vxy is equal to plus 36 plus 6, straight away answer 42, plus 42 rather, perfect. Next question. Wow, that's very quick, guys. That's very quick. Good. We got 2 different responses. Somebody saying none, somebody saying A. Let's see who is right. You also give in the comment what is your answer. It's not just the answer, analysis also important. The value of V in the circuit given. What is the V? What is the voltage? Current flowing is in this direction. Whatever may be the voltage source here, once you have this current source, current is always in this direction. The value is always 1 ampere. So this voltage is a plus 3 volts. So it is asked for this voltage, so it is minus 3 volts. Yes, Madhuteja, it's again diamond rule 2. That's what PiSquare's second rule. We have given these kind of amazing rules for making your concepts easy. All of you guys get ready for TGTRANSCO to be more precise. It's gonna come. Even Andhra people, Telangana people, whoever you are, get ready for it. Your objective is to get some preparation momentum with the help of this exam. Okay, it's not that you'll get it's TSTRANSCO sir, Telangana sir, AP people have less scope sir, all this sir. No, don't do these kind of thinking process. When you're in the preparation zone, prepare as if you have only one vacancy. It is given almost something close to, for electrical people, something close to 400 vacancies are gonna come. Telangana, close to 400 vacancies are gonna come. Get ready. Okay, total 5. Yes, total 5, because newly one more diamond rule added. Yes, you're right, buddy. Next question. Yeah, go for this. This is easy. This is one of the gate questions, but it popularly asked in couple of exams. It looks scary, but easy to answer. Good, guys. Good. Yes, quick answers you go.
ఎవరురా నువ్వు ఇంత టాలెంటెడ్ ఉన్నావు?
Yeah. Let's see what is E. Again diamond rule. This is 0 volt. Let me take it as this way, ground. And this is 10 volts. So this 10 volts, I'm representing it as like this. Any objection, guys? This is 10 volts. Any objections, guys? Madhuteja, think again and answer. So now I want E. Start here, come back to here. This is ground. Both are same. Like this. E is equal to -1, -10, -5. I gave this concept, Madhuji. -16 is answer. Not 11 volts. Yes. It's done. -16. It's not bye-bye, huh? There is one more question. I mean, there are a few more questions. Or shall we stop here? It's been 1 hour session almost. Okay, let's wind up here because our team has said bye bye, means time is almost close to 1 hour. So yeah, Banda Gurtu. I mean, they remembered it, but don't try to remember it that way, guys. It's good that you remembered, but rather you try to remember the concept behind it. Whenever you see this kind of a question, don't try to remember the answer, because they may tweak some of these points. Try to remember the concept to apply always. Then you will never get cheated. Okay. Power electronics. Okay, sir. Okay. Next session will come up with power electronics. Next session, tomorrow's session, will come up with power electronics. Till then, happy learning. Enjoy the learning in PiSquare style. Have a good time. And you guys, what you have to do, if you're not getting what the concepts, what I'm teaching here, just visit our website or download the app. You have got plenty of free videos. And the courses also, paid courses also at a very less price with the beautiful animations. PiSquare is India's only coaching institute with 3D animations to make you learn very easily. Okay, the PiSquare tagline itself, when we are committed to that tagline, what is the tagline? We help in bridging the gap with multiplied effort. We are doing that. You need to be ready for it. Okay, that's end of. We're easily chosen this type of question. We are easily chosen negative answer. Okay, good. So yeah, you guys, if there is some confusion, watch the free lectures at least at the first go. Okay, or you just go for this course. Think that one day if you have a biryani with your friends, it is gonna cost you this much. Consider that you're having a biryani for a whole month, not just for one session. Whole month you'll have biryani for the same one day price. Okay. Amazing classes in PiSquare Academy. Good. Thank you, buddy. Thank you very much. Happy learning. Enjoy the learning in PiSquare style. Have a good time. Bye bye.